So we're continuing with the next one that is on that table, which is x cubed, right, plus x squared, okay, minus x minus 1. Now, we are going to use a method called synthetic division, right? Synthetic division. Now, synthetic division essentially is what I would call a shortcut for the remainder and factor theorem, which is something we will tackle later. So you see, I'm doing the shortcuts first to show you guys how to get the answer, and then later I'll do the long methods, right? So I'm going to say this here is a shortcut for what? For the remainder and factor theorem. Okay? Remainder and factor theorem. Okay. So, interestingly enough, the factor theorem is something that you've easily been exposed to before. And I'm going to take this back to a quadratic, and we're going to look at that quadratic. Again, we're using that principle of relating old knowledge to new knowledge and new knowledge to old knowledge. So what does the factor theorem tell us? Let's choose a simple quadratic that you're very familiar with. X squared minus 3x minus 4. So when we solve for this quadratic, we say, okay, it's factors of what? Factors of?
4 that you add together.
Factors of 4 that I must?
Add together.
That I must subtract to give me 3. Right? That's 4 and 1. Because 4 minus 1 gives me the 3. That's x and x. And this here is going to be minus 4 plus 1. Okay? And that's when I make it equal to 0. Let's say I make it equal to 0. Then I can say, okay, from there I get solutions. And my solutions are as follows. X equals? Negative 1, or x equals? Positive 4. Now, two important parts of the terminology here is, number one, x equals 4 is considered a solution. What is this called? The solution. It's also called the root. Are you with me? Okay. And it's not just any solution. It's actually the solution to f of x equal to 0. In other words, when you make y equal to 0, what x value causes it to be 0? Are we good? Okay. This over here is also considered a solution or a root, right? Because it's the solution to the equation f of x equal to 0. Now I want you to look very carefully at this. This here, x minus 4, this is considered a factor. What's it considered? A factor. And this is really what we look at when we consider the factor theorem. The factor theorem says if x equals 4 is your solution, then x minus 4 is your factor. If x equals negative 1 is the solution, then x plus 1 is your factor. Are you guys with me? Yeah. So let's look at another example quickly. Let's construct one that makes it a little bit easier. Let's make it 36, right? Minus, and make this 5x, and make this x squared, right? So y equals x squared plus 5x minus 36. Okay. So if you read this mathematically, we're saying the following. We're going to be saying factors of 36 that you must minus to give you 5. And those factors are what? 9 and? You don't need a calculator for that. 9 and 4. X and x. Plus 5 minus 4. If I equate this equal to 0, I'm now looking for the solutions to the equation y equals 0. So from here you can tell me the following. That y must equal, x must equal to what? Positive 4 or x equals negative 9. Are we good? Okay. Now I want you to go over the terminology very carefully over here. Let's take violet again. And x equals negative 9 is considered what? A solution or a root, right? X equals 4 is considered a solution or a root. Now based on that, if you know x equals minus 9 is a solution, then what's your factor? X plus 9. Are we good? That's my factor. And if x equals 4 is a solution, what is the factor? X minus 4 is the factor. Now what I want you to do now as an exercise very briefly, I want you to substitute minus 9 into x there. And then you check what you get quickly. Okay, and then for the previous one, I want you to substitute in positive 4 in x and see what you get. Okay, you do that and you let me know what that looks like, right?